Leonardo. Thank you for joining this, intermediate Python class. You have joined the National Capital Region Chapter, and today our instructor is a volunteer with our chapter, and he's going to teach us a little bit about Python. So I will turn it over to Christopher, and you can talk a little bit more about yourself, Christopher.
Thanks, Eduardo.
Yeah.
Hey everyone. Like Eduardo mentioned, I part of the NCR chapter, and originally based out of Maryland. I'm a software engineer. I work on a threat detection team, and I thought it would be cool to run a workshop that focuses on the intersection of the two. So today we'll be writing a basic port scanner in Python. And let me go ahead and share my screen. I didn't prepare slides, but I do have some type of breakdown agenda for today's session. So can everybody see my screen?
Yes.
Yeah. Okay. Cool. So a little bit, just mentioned who am I? The motivation here, we're going to be automating a security related task, and I hope that this inspires people to continue using not just Python, but code in general to automate some of the day-to-day tasks. So what's out of scope for today's workshop is we're not going to be focusing on software engineering best practices. This is really just spinning up some scripts that can help us automate some day-to-day tasks. Also, we won't be deploying any Python applications. We'll simply just be running our script locally. And as mentioned, while we're waiting for people to join, there are a couple of dependencies. So please go ahead and clone the repository. It's in the Zoom chat. If you recently joined and it's no longer in the chat, let me know. I can send the link again. And then we're also going to be installing two Python dependencies, Colorama and PyFiglet. Okay. Did anybody have issues running into, did anybody run into any issues installing these? I saw something in the chat about Colorama. No. All right, is everybody set? Okay. All right, so the agenda for today is we're going to spend a couple minutes. Okay, Steve says he can't get past that error message. Okay, yeah, try installing them separate. I think I just assumed you could install similar to other dependency managers. I actually didn't run it in one line, so you can write install Colorama and PyFiglet. Yeah, exactly. All right. So the agenda flowing. Go ahead. Yes, sorry, I forgot to update the README before the workshop, but I'll take care of that soon. For the time being, I'll just share my screen, and when I get a chance, I'll upload it. And so we'll be spending a couple minutes reviewing Python basics, things like reading input, writing to a file, loops, if statements, exceptions, and then we'll jump into writing essentially three different versions of the port scanner. We're going to start off very simple, asking a user for a host and iterating over certain port numbers. Then we're going to go into reading a file that contains host addresses and ports, then writing the results to the file, and then if we have enough time, we'll go into the multi-threaded version of the port scanner to speed up our program. And then I do have a Q&A section for the end of the workshop, but feel free to interrupt me at any point if something doesn't make sense, or post your questions in the chat, and I'll go ahead and try to get to those as soon as I can. All right. Any questions before we begin with Python review? All right. Feel free to tag along, run some of these programs on your machine, and then yeah, we'll speed through the basics review so we can get started on the port scanner. So a couple of things. We'll be reading input. So what we'll be using is the input function for this. So a quick example of how to use that is, say we want to ask a user for their name. We can simply use the input function and say, what's your name? And then we can do some processing with this information that the user put. So say we want to prefix this with something like hello name, then we can print out this variable hello name, and we should see something like we should be asked for our name here. My name's Chris. Oops, that printed the wrong file. Sorry, we gotta rename this. Okay, so we have, what's your name? Chris. Hello, Chris. All right, there's a basic example. Onto the next section is writing to a file. So say then we want to write this input to a file. So we can use the open function. So here we'll be storing, what we'll be creating this file called hello.txt. And one of the parameters we're going to pass is the letter A. That's to let Python know that we want to, one, we want to create this file if it doesn't exist already, but we're planning on appending to it if there's already content in it. We don't want to overwrite what already exists in the file. So then we can go ahead and write our variable hello name, and we're just going to go ahead and add a new line character here. And for every file we open, we want to close it as well. So let's go ahead and write your name. It should print it out, and then you should also have a file created called hello.txt that prints out the content. Okay, I had already previously run it, so it appended the hello name twice on mine, but you should only be seeing it once on your end. Okay, now into loops. So I'm going to create a list here of a couple of names. Shout out to some of the people in the DC chapter. Let's see. And then let's say we want to iterate through this list. We can use a for loop here saying for name in names, and name will be the current value that we're iterating through in the list. So we can go ahead and print this out as well. Okay, so I'm going to comment this up here so we don't run into that twice. Now you can see we've iterated through this list and done some processing on each variable. Okay, but what if we want to handle some special conditions? We want to use some if statements. So if you're a new member to Raices, we can print welcome to Raices. If you're not a new member, then we'll say welcome back. Go ahead. Comment this out. Okay, welcome to Raices, because we set our new member variable to true here. And last but not least, we have exceptions. So certain functions that we'll be using for the port scanner will throw errors, and we need to catch these errors and do some we need to react depending on the type of error we receive. So for our case, we want to use, we're going to use a infinite loop, and we want to catch when somebody exits the program from the keyboard. So in case your program is running too long, we want to gracefully handle you exiting the port scanner, for example. So here we're going to be expecting a keyboard interrupt error. And we can print out and then the line exiting program. Okay. And the sleep function, I believe, is not imported by default, so let's just write a quick import statement here. And we should be stuck in an infinite loop until we exit the program from our keyboard with Control-C. There you go. Okay, it looks like we might need to import this as well. So it should, there you go. So we've successfully handled our Control-C error here. Okay, I know that was pretty quick. Is there anything that you guys want me to dive deeper into? Anything that you want me to go back to? Any explanations that need to be done before we move forward? Any questions? Okay, I'll take that as no questions. All right. When do you use try? Okay, good question. So you use try when you know that the indented block is gonna throw an error. So there are certain function calls that will always return that may return an error. And so instead of exiting the entire program at times, you may want to you may want to continue doing something else before exiting. So that's usually when you use try block. So you're saying try this, and if an error occurs, do something else. So in our case, we're saying, try this infinite loop, and if we receive the error that if we receive a keyboard interrupt error, let's print out that we're exiting the program and then exit the entire program. So usually you can use the accept block to maybe do some cleaning up if there are some resources you want to get rid of or anything you want to do before you exit. Mm-hmm. Yes. Yeah, I believe you can add any number of accept blocks. All right. Any other questions? All right. So if you if you clone the repo locally, there should be a file in there called skeleton.py. It's essentially some setup that I already did for us, things that don't really require too much diving deep into, but that'll save us a lot of time, given the 1 hour time block that we have. So I can quickly go over what's already in skeleton.py, and then we can get into writing some of the code. So just for fun, I thought it'd be cool to add some color and some limited UI to our port scanner. So that's why we're using this library called Colorama and PyFiglet. It allows us to specify certain colors for our command line output. So that's what's happening in lines 8 through 12 here. Nothing too crazy. You can change the colors if you like. this is what is pretty straightforward to start off with, and with the tutorial I had gone through for Colorama and PyFiglet recommended. So yeah, this isn't required for any of the work we're doing. It's just simply to make it look pretty. In a similar sense, inside the main function here, we have an ASCII banner printing out port scanner. I saw this online as well. I thought this would be pretty cool. Makes it feel more like a legit command line program that we'll be writing here. And in the middle of the skeleton file, lines 20 through 28, this is a bit more of the advanced stuff. This is getting into the multi-threading portion of the port scanner, and I can dive into this section when we get there. I'd like for us to just focus on steps 1 and 2, and then I can answer any questions you guys have about this when we get to step 3. And I know these aren't the best or I guess the friendliest names for functions. I just thought it was good to kind of distinguish the different sections of the workshop. Cool. And down here, we just have a main function ready to run the steps that we create. And you'll see in our block down here, we're actually using the try except. So that if at any point, for example, the port scanner is taking too long, you can exit without seeing the entire stack trace on your command line. So it cleans it up a little bit better. Okay, so let's go ahead and start with step 1. So as I mentioned, we want to write a very basic port scanner. So we want to ask the user for a host address. Then we want to iterate over all the ports, check if any of them are open. And then if they are open, we simply want to notify the end user, which is us, through the command line, what ports are open and which ones are closed. So we'll start off with a function up here above step 1. We'll call this port open. And this is just going to tell us, this is going to return true or false, whether a certain port is open. So here we're expecting the host and the port variables. So given these two values, we should be able to we should try to establish a connection to that host on that port and then return a true or false value. So the way we'll be doing this is we'll be using Python's built-in socket library for network sockets to establish a connection to our host. So we've already imported socket here. There's no pip dependency. This is already built into, it comes with Python. So let's go ahead and create a new socket. And then the connect function that we want to call actually returns an exception. So we want to wrap this in a try block, and we just want to see if we can connect to the host and the port. Okay. Optionally, if you want to do this, if you want to work on this moving forward, you can also set a timeout value for the connections if you don't want your program hanging for too long. So I'll just leave a comment in there. Okay. So if we get an exception, it might be like a timeout exception, whatever it is. We know that we've failed to connect to this host on this given port. So we can just go ahead and return false here. If that's not the case, if we're able to connect successfully, there are no exceptions thrown, then we can just go ahead and return true. Cool. So all we're doing here is we're creating a socket and we're trying to connect to the given host and port. Does that make sense? All right. Okay. So now what we want to do is we actually want to run this on a range of ports for the given host, right? So let's go ahead and just define a function called scan. and we'll expect the host address to be passed in. And let's say we want to iterate through, let's see, iterate through ports 1 through, I think the largest one is 655, 34, I believe. Okay. So using a for loop.
35.
Oh, 35? Okay. So we'll use a for loop here to iterate through the entire range here. So we have port in range 1 through 655, 35. We want to check, is this port open? So we'll call our port open function. We'll pass in the host, pass in the port, and then we want like success message here. Else we want like I guess failed connection message here. So here we'll just be writing a print statement to the screen for now. We'll be using the colors that we imported earlier to make this look nice, a little bit easier on the eyes. So go ahead and use green color. We'll add plus sign. Let's post some information here. So we're saying host port is open. Okay. And then for the failed message, we'll use the other color we set, which is, I believe, gray. This. Okay. So now we have a function that'll iterate through all the ports for the same host and calls our port open function to see if that port is open. So now we can run all of this as our basic port scanner as step number 1. So all we need is all we need now is the host address, so we can ask the user enter the host and then scan the host. Okay. So now let's try running step 1. Just gonna go ahead and uncomment this. Okay. Let's go ahead and run it. Skeleton.py. I'm gonna comment this out for now. Let's see. Okay, it's not happy about these empty blocks. So let's comment those out for now. Okay, cool. So we have this ASCII banner for the port scanner, and I'm just going to type in localhost. I want to scan my own machine, and let's see what happens. All right, so that seemed a little bit too quick. So I'm actually going to update the print statement with there's the option in Colorama, I believe, to reset this so that we're not printing all over our screen, but rather printing in place. And that'll make more sense in just a couple seconds. I'm going to run this. Again. Okay. So now we just have this running in place, and we only want to keep the green messages so we know what ports are actually open. All right, so as you have this running, note that it's going to take a while for this to complete. It's going to take at least, I'd say at least a whole minute. I think the last time I ran it was maybe like 2 or 3 minutes. So we have that running. Does anybody have any questions? All right. Is anybody running into any issues running this locally? All right, we're almost at 65,000, so this should wrap up in just a quick second. This is essentially it for step number 1. So we're just asking the user for host address and then scanning all the ports. So this is just scanning my machine, printing out what ports are open. And then, yeah, we can then move on to step number 2, to start reading and writing to files. Let's wait for this to wrap up. Cool. Ta-da. So now you have a list of all the open ports. Okay. So let's say, you don't want to manually run this for one host, or, you don't want all the output on your command line. What can be really handy in this case is reading in the hosts and the ports from the file, and then also, outputting your results to some other file, which, you can use either as a report or to supplement a report. All right, so let's go ahead and get started on step 2. Okay. So let's go ahead and uncomment this block we have here. All right. So since we're going to be reading from a file, I actually included in the repository a Python file called the writeinputfile.py. All it does is it creates a line for every single host port value on your machine. And it creates this file called host.txt. So I added this in here in case you want to follow along. This is probably the easiest way to test this with a lot of hosts and ports. So it just creates this file here. You can see it has local host and all the ports. And the code we'll be writing will be parsing this file and then scanning all of the values in here. So in practice, you might have a bunch of different IP addresses with different port numbers, and the code we'll be writing should be able to handle that case. So if you want to go ahead, you can just here, I'll go ahead and delete my host.txt, and then I'm just gonna create this again. Write info file. Boom. Quick. Okay. So now we have our host.txt file. Let's go ahead and start writing the code to then read files. So we'll create this function called read file. We'll pass it a file name parameter so we know which file to open. So from the review we had earlier, we're going to use the open function. We're going to open a file, but this time instead of writing to it, we just want to read it. Also, we know that our values are separated into lines, so we actually want to store each individual line, so we can then do some processing on the lines. So by calling read lines on the file, it returns a list of all the lines in the file. Okay. And then what we want to do is we want to store our host port values. We're going to store them as tuples. We'll just have them in a list for now. So we're going to iterate through every single line, and this is what our file looks like. But essentially, we just want the host and we want the port. We want to get rid of the semicolon. we want to get rid of this colon. And so we're going to do a little bit of parsing here. So we're going to say for each line in the file, we want to, first off, we want to go ahead and strip anything, any like new line characters. So this doesn't give us any issues. Then we want to go ahead and split our string. So we want to split our string into a list of strings by using the colon as a delimiter. So this should then just return, we'll go from like localhost 30 to a list of localhost and port 30. All right, so we know the host is the first value in the list, so we can get the host there. And since they're stored as strings, we actually need to convert our port into an integer. And this is important because the socket function, the socket.connect function, expects the port to be an integer, not a string. Okay. So now we have our host and our port, and now what we want to do is we want to store them as tuples. So we can go ahead and append. We'll be defining the host port tuple here and then appending it to our list. And we just want to go ahead and return our host port tuples. So we're reading a file and we're returning all of these host port values as tuples, which will allow us to easily do some of the processing. Processing in this case is the scanning. Cool. So now that we have these tuples, let's go ahead and scan them. So we can define a function called scan tuples. We'll keep the same name for our list here. And once we know what we want to do with the information, we're going to want to store it somewhere. So in our case, we're going to want to write it to a file. So let's set that up now so that once we're done processing, we can just go ahead and store results. So we're going to use open again. This time, just create another file called openports.txt. We want to append to it. And then let's go ahead and iterate over hosts ports. So for each host port in our host port tuples list, we want to call our port open function from earlier. So we just want to check if the port is open. We want to say if port open, pass hosted port. And then we want to write to our file the results. So we have a variable f representing our file, and then we can just write this formatted string. It says host, and then port, similar to the file that we read in, just identifying which host ports are open. We'll go ahead and add our new line character here as well. And once we're done iterating, let's not forget to close our file. And then we just have a print statement here to let us know where we're at. So output written to open ports.txt. Cool. So we have the function to read our file, and then to parse our host and ports. Then we have a function to process the host and ports and write our results. So that's pretty much it for step 2. Now we just want to piece it together in our run step 2 function. So here, let's go ahead and ask the user for a file name. So let's say enter the file name containing host port values. Okay, once we have the file name, we want to read off the host port tuples using the read file function we created. Let's go ahead and open that file, get all the tuples out of it, and then we want to scan all of the tuples and write the results to open ports. All right. So it looks like our step 2 function is ready to run. I'll go ahead and comment out step 1 function. Let's see. And remember that we'll be using the hosts.txt file as our example here. Okay, enter the file name containing the host port values. We're using hosts.txt. And see, we're no longer getting the output on the command line because this is just writing our output to a file. So it might take some time before you see the program end, but upon completion, you should have a newly created file in your directory. While we have this running, do we have any questions? All right. Sweet. So our program finished running. So we have our output into openports.txt. So you should have a new file. And so instead of outputting it to the terminal, we have all of our host ports that are open. So now you can take this file, you can do whatever you want with it. But you see how now you have that information stored somewhere. Okay, that's essentially the end of step 2. We've already gone from supplying a simple host address to the command line and scanning all the ports to then reading a file containing host port values and outputting the results to the file. And now we'll go to step 3, which is speeding up the process here by using threads. Okay. So you can go ahead and uncomment the values that we had originally, lines 69 through 77. So these are number of threads here is just the default value I set for the number of threads we want running at the same time. This is kind of like the ceiling for the number of threads. You can go ahead and adjust this, play around with it. We're not really going to be testing out the performance of tuning the threads. So that's something that, feel free to do after the workshop. We'll just be using this 200 default for now. We'll be using the queue implementation from Python to send out work to our threads so that the threads can then process or scan all the ports almost at the same time. And then we're going to be using a thread lock to ensure that we're safely printing our output without having any conflicts between the threads. We don't want them trying to print at the same time or messing with our program. So we'll be using a print lock here. Okay, let's see. Okay, so we'll start off with the print lock because this is pretty important. We essentially want to do the same scanning that we've done in the previous 2 steps. The difference is we want to set our lock. We only want to print when we have our print lock. So we're going to update our scan function essentially. So we'll have scan the host port here. It's going to look very similar to the previous functions. We're going to write the if statement if port is open. We want to say with the print lock this time. So essentially the thread has to wait until it gets the lock to print the statement now. And then I'm just going to go ahead and copy our success message here. Okay. Cool. So that's all we want to do. We want to say if it's successful and just print which port was open. All right. Now we need to define the work that the threads are going to be consuming. So this part might get a little tricky. It'll make a little bit more sense once we're done writing the code for this section. But feel free to send any questions in the chat or unmute yourself and interrupt me. So we're going to be defining this function called scan thread, and what this is doing essentially is it's defining how the threads consume work from our queue. So say this pulls work from the queue and processes it. You'll notice we haven't set up anything in our queue yet. We'll get to that after defining the consumer. So we're just going to have an infinite loop here, and we're going to retrieve from our queue. So as you can see here on line 75, we define Q as the letter Q. So we're going to get an item from the queue. And then we're going to run scan host port on that item. Thing is, what we're sending to the queue is going to be a tuple with the host and port, just the way we did it in the previous step. So worker here is actually going to be a tuple. So that'll be the host and the port. And this will make more sense right now when we get to the producer of the work. And we just need to let the queue know that this piece of work has been completed once we run the scan host port function. Okay. Let's see. We need to set up our threads. So the consumer work, like the work being added to the queue, is going to come into play when we wrap up our run step 3 function. So bear with me while we get through this setup threads call. So we're just going to say for t in range number of threads, this is where we create the number of threads we set. We want to go ahead and use the thread function Python, and we want the thread to run the function we defined here. So each thread is then going to consume from the queue, run this function, and then notify the queue that it's done doing its work. So we just point to the scan thread function here. We want this to be running in the background. So we're going to set the daemon configuration to true, and then we just want to start the thread. So now we have these threads running in the background. If we were to run this now, nothing would be happening because the queue isn't populated yet, so there isn't any work for the threads. All right, so let's give them some work. Let's go to step 3 here. So we're going to call our setup threads function. We want those running in the background. We want to ask the user for file again. So enter file name containing those 4 values. We want to read tuples, just like we did in the previous step. And then for each tuple, we want to send the tuple, we want to add the tuple to the queue. So now this is where we're actually producing work. So we'll label this as a producer. We're just adding tasks to the queue. Okay. And then the last step is we don't want our program to end until all of the tasks have been completed. So the queue has this function called join, and it essentially waits for all tasks on the queue to be completed before ending the program. Okay, so if we try running this now, I think we should be seeing much better performance. Instead of a couple of minutes, it should take a couple of seconds. So let's go ahead and try this out. We're going to be using the host.txt file again. All right, we've already got a couple of ports that are open. All right. According to VS Code, this took 17 seconds, which, significantly better performance than running the port scanner in a single thread. And that is the last step of our port scanner today, and the last chunk of code for this workshop. I know we went through that pretty quickly. Are there any questions, any steps that I can go back into, anything you want me to dive deeper into?
Remember, guys, you can unmute yourselves and ask the question. It doesn't need to be in the chat.
Please mind sharing the code on the same repo. Yeah, Joanna, I'll be adding the completed script. I just didn't want everybody to start off with the completed script at the start of the workshop, and they can just reference it afterwards. It'll also have the updated README with the breakdown of what we covered, and I added some definitions I found online for sockets and threads, in case that's something that interests you. All right, well, that's pretty much it for me. A bonus, if anybody wants to keep working on this, is maybe adding some type of enrichment to then identify the services you're running on these ports. But other than that, that's it for today's workshop.